The discovery, lights from afar. The James Webb Space Telescope, humanity's most powerful space observatory to date, has recently made a discovery so extraordinary that it could redefine how we understand the universe. It has captured something truly astonishing: faint, shimmering lights that appear to be emanating from what looks like a cityscape, but not a city on Earth. No, these lights are coming from a distant location nearly 4 light-years away, far beyond the reach of any spacecraft we've ever launched. This jaw-dropping finding has reignited global curiosity and fascination about the possibility of intelligent life existing beyond our own planet. It's the kind of moment that makes us stop and ask the big question: what if we're not alone after all? Could it be that somewhere out there, alien civilizations are thriving? Societies might be evolving in entirely unfamiliar ways, lighting up their cities with technologies we haven't even begun to imagine. To make this remarkable observation, the James Webb Telescope turned its gaze toward Proxima Centauri b, an exoplanet orbiting Proxima Centauri, the closest known star to our solar system. This rocky planet had long been of interest to astronomers due to its relative proximity and Earth-like characteristics. But then came the unexpected. The telescope detected mysterious, bright flashes of light. These were not typical cosmic events. They weren't meteors, solar flares, or the glow of a star. These pulses were rhythmic, steady, and fixed in place, almost as if they were being produced by something artificial. Could these lights be signals? The glow of alien technology? The nighttime glimmer of cities on another world? The possibility is breathtaking. For decades, scientists, philosophers, and everyday dreamers have looked up at the night sky, wondering if someone or something might be looking back. And now, with this new evidence, that timeless question suddenly feels more real than ever. The James Webb Space Telescope recorded these lights as persistent and stable, remaining anchored to a single location on the surface of Proxima b. Natural phenomena tend to flicker, fade, or move with time, but not this. This seemed different. Engineers and astronomers at NASA were stunned. Some even asked themselves, how long have these lights been out there glowing in silence, waiting for us to notice them? Could they have existed for centuries, their faint beams traveling through the darkness of space, only now reaching our eyes thanks to a telescope finally powerful enough to see them? David Kipping, a prominent astronomer at Columbia University, described the exoplanet as particularly complex, unlike most rocky planets, which absorb energy from their star and re-emit it in the form of heat. Proxima b showed signs of behaving differently, likely due to its close and unusual relationship with its host star, Proxima Centauri. This is where the James Webb Space Telescope proves invaluable. With its unmatched ability to observe in the infrared spectrum, it can detect thermal emissions, light fluctuations, and chemical fingerprints invisible to the human eye. The data collected so far reveals that what we're seeing is more than just a visual curiosity. It could be a clue, a window into the atmospheric makeup and surface activity of Proxima Centauri b, a possible sign of something remarkable. Thanks to the telescope's precision, we are now closer than ever to identifying whether these glowing lights are simply natural marvels or evidence of something truly beyond our current understanding. And if it is the latter, it would not just be a discovery. It would be a turning point in human history. The implications: are we alone? The true power of the James Webb Space Telescope lies not just in its ability to look far into space, but in its ability to see what others can't, to detect even the faintest whispers of light across unimaginable distances, and reveal the hidden stories written in the starlight. Its sensors are so sensitive that they can isolate artificial light, the kind generated by technology, unlike the broad-spectrum glow of natural stars. This ability makes the telescope an ideal tool for searching for alien civilizations, because artificial light, if detected, could serve as a techno-signature, a clue that intelligence exists beyond Earth. The lights coming from Proxima Centauri b, if confirmed to be artificial, would represent the first solid evidence that we are not alone in the universe. And that would change everything. But to fully understand what's happening on this mysterious exoplanet, we need to learn more about its atmosphere and surface conditions. Proxima b is a rocky world, much like Earth, but it orbits very close to its red dwarf star, which means it experiences intense heat during the day and extreme cold at night. If the planet lacks an atmosphere, this temperature difference would be severe, with the sun-facing side scorching hot and the dark side frozen solid. However, if it does have an atmosphere, it might be able to distribute heat more evenly, moderating these extremes and possibly creating a habitable zone. The presence of an atmosphere would be a major breakthrough, a vital step toward confirming that the planet could support life. That's why researchers are now using the James Webb Telescope to study its atmospheric composition. Thanks to its synchronized orbital pattern, the telescope is able to revisit and observe Proxima Centauri b in detail every 11.2 Earth days, allowing it to track thermal variations, changes in brightness, and even seasonal shifts. If the planet does have an atmosphere, the next task is to analyze its chemistry. Scientists will search for key markers of life such as oxygen, methane, carbon dioxide, and water vapor. These elements don't just indicate the possibility of life. They tell us how likely it is. While the Webb telescope isn't perfect at detecting free oxygen, it excels at identifying other essential biosignatures like ozone and carbon compounds, which can point to biological or even industrial activity. These clues, taken together, may help build a case for life beyond Earth. But there's a limit to what even the Webb telescope can do. It can only observe a relatively small group of nearby exoplanets in significant detail. To go further, we'll need the help of future telescopes. That's where the Extremely Large Telescope, ELT, comes in, a groundbreaking observatory currently under construction, scheduled to begin operations in 2028. Located on Earth, this massive telescope will be able to collect more light and provide higher resolution data, giving us an even clearer picture of distant planetary atmospheres. To enhance the detection of alien worlds, scientists are also developing new techniques to overcome a major challenge: starlight. Stars are so incredibly bright that they often outshine the faint light reflected by the planets orbiting them. This makes it extremely difficult to study those planets in detail. To solve this, astronomers are working on light-blocking technologies. One such tool is the coronagraph, a device placed inside a telescope that blocks out the overwhelming starlight while allowing the dim light of surrounding planets to come through. Another revolutionary concept is the Starshade, a massive, flower-shaped spacecraft that flies thousands of kilometers ahead of the telescope. Its purpose is to cast a shadow over the target star, so only the light from nearby planets reaches the telescope's instruments. These technologies require unimaginable precision. The alignment of the starshade, for example, must be accurate down to a fraction of a millimeter, despite operating across distances spanning tens of thousands of kilometers. But if these challenges can be overcome, the reward will be immense: the ability to directly observe the atmospheres, surfaces, and even weather systems of distant exoplanets. Future space telescopes may also use adaptive optics to correct for distortion caused by Earth's atmosphere or telescope movement. This will result in sharper, clearer images, bringing alien worlds into focus like never before. Together, these tools and innovations represent a giant leap in our ability to find and study life beyond our solar system. We're not just looking for planets anymore, we're looking for civilizations. We're searching for signs that someone else is out there, living under a different sun, walking beneath a different sky. Each new mission, each new telescope, and each new piece of data brings us one step closer to answering the question that has echoed through the ages: are we alone in the universe? And if the answer is no, if we find that life does exist beyond Earth, it will change not only the way we see the universe but the way we see ourselves. Let us know what you think in the comments below. If you enjoyed this exploration into the unknown, be sure to like, subscribe, and stay tuned, because the cosmos